Hi everyone, I am Gagan Chandra Motamari and I have worked with Parlay Finance for the Data Science Capstone course. And this is the final project presentation and my manager name is James Cho. Let me introduce you to Parlay Finance. Parlay Finance advises borrowers on the kinds of loans they can obtain and the kinds of loans that lender can offer them. Loan evaluation is based on score-based systems which uses business credit score, personal credit score, loan amount and revenue, and there are more 4 to 5 parameters which affects the score, and all the scores are out of 100. Lenders apply different score cutoffs. Coming to the project overview, our goal is to build a single multi-label machine learning model to classify loan applicant fit across multiple lenders and loan types. Currently, they use traditional scoring evaluation of parameters as we discussed in the introduction. And why is machine learning model matters? Traditional loan evaluations are manual and time consuming. Lenders need an efficient, accurate way to access credit fit. Now, what are the benefits of machine learning model? It reduces complexity, improves consistency and handles data efficiently. Coming to the problem statement, as we discussed in the project overview, SBA evaluations are time consuming and complex, and applicants struggle to navigate SBA regulations and lender requirements as different lenders have different rules and regulations. And lenders also requires efficient evaluation systems while ensuring compliance. So what is the solution for this? We are developing a single multi-level machine learning model that integrates applicant profile and generates unified fit scores. Basically, we recommend what are all the loans that a particular applicant can get. Coming to the solution strategy, what data are we using? So Parlay has provided us 50 applicants data, which has 46 columns, where one column is our target, which is eligibility column, and we have wrote a Python function which generates synthetic data. Some of the features of that function are we extracted unique business structures and NAICS codes for industry alignment, and we have simulated revenue and debt patterns for realistic application scenarios. There are more considerations which are considered while writing this function, and the key metrics or the key columns in the data are DSCR, debt service coverage ratio, net profit margin, ownership structures, loan amount and type of industry. I've included sample image of our dataset so that you guys can see what the target eligibility column looks like. There are four types of loans: 7A, 504, 8A and Express. If nothing works, it's ineligible. So this is the sample dataset. So after generating the synthetic data, we need to generate the values of the target column. So the company has given us certain conditions like what are the required parameters for a candidate to get a certain type of loan. So there are four type of loans and there are different conditions for each parameter for an applicant to qualify for a single loan. So as you can see, there are four different conditions for all these four types of loans, and using these conditions we have written a function and we'll pass our synthetic data into it and we'll get the target column into our hands. Now we have our data. Next we did exploratory data analysis, and I have not included that here, and the problem we have identified is loan categories were highly imbalanced. The ineligible data is more for us rather than the other loan categories. So we used smooth technique to balance data, which basically generates synthetic data, and after this all the labels in our dataset are well balanced and equally numbered. So also we applied feature engineering. We have created new columns like risk score calculation, which is calculated using DSCR and depth to income, and we applied polynomial log transformations for skewed data, and also we have categorized business age. Next, we created four models: neural networks, XGBoost, Light GBM and Transformer. For neural networks, we use simple sequential model, and as you can see, best performing models are XGBoost. It is getting around 87% of accuracy, and the F1 and recall scores of all the categories and labels are balanced across. And for light GBM, it is faster, interpretable, and good trade-off in accuracy. And for tap transformer, it is giving strong generalization and better for categorical data. Overall, I feel light GBM and tap transformer are the best models till now. And in terms of hyperparameter tuning, we did hyperparameter tuning for all the models, like for XGBoost and LightGBM, defining trees, learning rate, and for neural networks, we tried different epochs. Same goes with the tap transformer as well. So I've included model performance as well. The first one is XGBoost, second one is Light GBM, and third one is Tap Transformer. As we can see, all the models are overfitting for 8A category. As while generating data for 8A, we only had 3 or 4 parameters for the consideration. So this is the reason why it is overfitting for 8A. But it doesn't matter because it's a non-profit loan, so we can easily classify it. So on the right side, as you can see, it is the classification report for ensemble technique. And on the left side, I've included a model accuracy comparison plot where you can see the last one, ensemble stacked model. It is overfitting as it is getting 99% accuracy, while ensemble weighted average technique, it performed pretty well as it got 83% accuracy. And I also removed 8A category from this, as we have been told that it is not important to classify this category, and it improved our model performance on ensemble technique. As you can see, the recall, precision, and F1 score are pretty much around 70 to 85 percentage. This is well for our classification. As you can see on the left hand side, I have included Lime explainability. So this is for a particular applicant. So we can do it for all the applicants in our data or anything. And on the right side, you can see I have included a column named final decision, where for each applicant, it is giving further review needed or strong approval. By this, you can go back and check the applicant's data if it is further review needed, and if it is strong approval, I am pretty much sure that you can give the particular loan to that applicant. Coming to the interesting findings and interesting approaches for this project, the pipeline integrates SBA regulations and endless specific credit criteria, ensuring automated compliance checks. This reduces manual errors and inconsistency in loan eligibility assessments. We have used risk-based feature engineering to improve model interpretability, also applied smooth and random oversampling to handle imbalanced data, and equal representation across all categories to avoid noise. Coming to my experience on this project, uh, the challenges faced are handling imbalanced data while maintaining model performance. And the second one is the most important one. Working with synthetic data is hard while building a real world model. So we have to need some real world data for this, because it's becoming so hard for the synthetic data to find all the patterns, to note all the patterns, and get good performance on a particular model. And we need and one more thing is, challenges I have faced was finding the right balance between recall and precision. And lessons learned: feature engineering plays a major role in financial methods, and class weightaging and over sampling techniques improves fairness in ML models. My personal takeaway is this project provided real world exposure to financial data processing and model optimization and fairness in lending decisions. Coming to my contribution in this project, I've contributed equally in this project in all the steps. In data generation, I've generated synthetic code using well-defined Python function, did exploratory data analysis. In data cleaning and pre-processing, included smooth and oversampling to avoid imbalance in the target column. Also, in while building machine learning models, I've did XGBoost and Live GBM, which in both of them I've did hyperparameter tuning and got a good accuracy for XGBoost of 87%. So coming to the conclusion, As you can see, a single multi-labeled machine learning model has provided us uh, loan evaluation and reduced inefficiencies. And as in the previous slides, I've explained that about the models, and XGBoost and LightGBM proved as the most reliable models. And feature engineering and data balancing are significantly in was impacted on classification results. By doing feature engineering and data balancing, you can our results improved, and this project helped me to gain a lot of knowledge on working on machine learning models and finance data. It really helped me to brush my machine learning skills, and I also learned a new skills uh, in finance. I had no experience in finance industry. Now I have a pretty much good experience and how about the terminology which they use in finance, and it is a great project to work on. And thanks for the opportunity given by CU Boulder and Amy Gates. And I'm very much thankful to my manager James Cho, who has been uh, worked hard. Like he has been very good with us, and thanks for the opportunity.